Alrighty, another related rates problem. I think the first thing you should do here is draw a picture. So, girl, Sierra, 5 foot tall, she's running from a 20-foot light pole at a rate of 6 feet per second, and it's asking how's the length of her shadow changing. So, I'm gonna draw this in a couple different ways, a little bit differently than on the study guide. So this is, or on the PDF. This is 25 feet. Actually, no, I'm gonna keep my units. So that's where the light's shining down from. Then this girl Sierra is right here, and that is 5 feet. You can imagine that her shadow is going down. It's getting cast right there, coming down right here. Her shadow length is this guy right here. So her shadow length is not the entire length of that bottom triangle. If you imagine her feet are right here, right? So the length of her shadow is from the bottom of her body out to the tip of that triangle. That I'm going to call X. Hopefully you're okay with that. The other thing I could label is that she is moving at 6 feet per second. 6 feet per second. That would be, well, we'll talk about that in a moment. Alright, so, this distance is the other one that I'm kind of concerned about here. And you can do this in multiple ways, but I think it's easiest to think about this one right here. If I call this Y, now, it starts, so it says when she is 40 feet from the light. So it's originally 40. And she's running, right? So that number is increasing. So she tells me, or they tell me that that she is running at 6 feet per second. So that Y is increasing at 6 feet per second. And that's why I choose to break it up in this way and not look at the whole triangle. So you should see why dy dt is this 6 feet per second right here. And that's because that she starts at 40, right? Or that's when we're looking at it right there, and she's running at that rate, right? Okay. So I'm going to go and kind of redraw these triangles. I've got the big one, which is 25, and this full length is, well, it's first Y, it's Y, and then it's X, right? So that length is Y plus X. Then I've got the little triangle that's 5 feet here, and then this length is X. And these are both right angles, and that angle are the same, right? Could do the top angles too. So I know that these triangles are similar. So I can set up a ratio with these two triangles, kind of explaining that similarity. So we'll do it in red. The 25 over, I'm going to write X plus Y, is always going to be the same ratio as the 5 over the X. All of those of you who had me for geometry way back when, hopefully you remember this. What was that, like 4 years ago? Alright, so from here I cross multiply. So I get 25x, so that's this, equals 5 times x plus y. That's this. So continue on. 25x equals 5x plus 5. Actually, what I'm going to do before I do that is look at it and say, well, sure, I'll multiply it out. I get 25x equals 5x plus 5y. Now I look at all the terms and say, oh, everything's divisible by 5, so why don't I divide everything by 5 and make it easier to work with? So that gives me 5x equals x plus y. And now I can move that x over to the left-hand side and get, so I'm going to continue my work over here so that I can keep that other stuff up there. So when I move that x over, I get 4x equals y. Now, I could have tried to derive the whole thing here, and it would have been a complete mess, and it would have been terrible, and I would not have enjoyed it. The reason why I did all this simplification is because now this is suddenly really, really, really easy to derive with respect to t. So I get 4, well, what's the derivative vector with respect to t? Well, we call that dx dt equals y, what's the derivative of y with respect to t? Well, we call that dy dt. So from here, remember, I knew that dy dt was that. Let me actually scroll back up. So they're asking how, I'll even go all the way up. What rate is the length of her shadow changing? X is the length of her shadow, right? So what we're looking for is dx dt. Notice down here, I know that this is dy dt, so I can plug it in, and then I have dx dt all, and that's the only variable left. 4 dx dt equals 6, which I solve, I divide by 4, get dx dt equals 6 over 4, which I can simplify to 3 over 2. And I should give my units, it's feet per second. And I can always figure out my units. I've got x over time, so it's feet over time. And that's your answer.